Hello class, in this lecture I will demonstrate how to solve a simple forecasting problem using Excel. We'll do problem number 14 on page number 688. Please read the problem before you watch this video. I have slightly modified this problem to include more questions. Here we have to answer these 5 questions. The first question is we have to construct a time series plot and we need to identify the pattern in the data. Remember, the technique that's demonstrated here in this lecture video will only work with the horizontal pattern in the data. If the data has any cyclical pattern or seasonal pattern or trend or any combination of those patterns, the technique demonstrated here might not work. So to find the pattern in the data, we'll select the data set, go to Insert, and select the scatter plot here. And you can always add axis titles here. So on x-axis we have sales, months, and on y-axis we have sales. So if you look at the pattern in the data, it does look like a horizontal pattern, which means that we see only random variation around the mean value. We don't see any trend going up or going down, and we don't see any cyclicality. So this is an example of horizontal pattern, and as I said, this technique or all the methods demonstrated in this video will only work with the horizontal pattern in the data. So again, you need to have all the variation of the data points around the mean in a straight line. So this is what we saw here, and this is like a horizontal pattern. So we'll move on to question number B here. So compute a 3-month moving average forecast for this time series. Compute a forecast for month 13th. Also compute MAE, stands for mean absolute error. MSE stands for mean squared error. And MAPE stands for mean absolute percentage error. So we always want our forecast to be as accurate as possible. A forecast is simply a prediction of what will happen in the future. Managers must learn to accept the fact that regardless of the forecasting techniques they will use, they will never be able to produce perfect forecasts. There will always be some error present in the forecast they generate. So forecast error is basically given by the actual value, actual sales value minus the forecast, and that will give us the forecast error. To increase the accuracy of our forecast, we obviously want to bring down our forecast error to as low as possible, possibly 0. That will be the ideal condition. There are many ways to measure the forecast error. We will focus on 3 such measures: MAE, MSE, and MAPE. These measures simply tell you how much forecasting error is present in the time series. It doesn't tell you how to lower them. Often you compare forecasting errors produced by different techniques such as 3-month moving average and exponential smoothing and select the one that yields lower error. So if you wish to compare 2 different time series of the same product, like we're going to do it here, MSE is most commonly used. So MSE stands for our mean squared error. But if you wish to compare 2 different time series for 2 different products, then MAPE is mostly used because it is unitless. It's simply the ratio of 2 numbers. So first we'll consider 3-month moving average. That's what we need to do it here. Here we use the average of most recent 3 months sales as a forecast for the next period. So there won't be a forecast for the first 3 months because we're going to use that to generate the forecast for our 4th month here. So here I will simply put the formula here equals average of first 3 months. It was 120, and I will drag this one down, and I'll go a step lower because we've been asked to calculate the forecast for the 13th month. I will highlight this one. So this is how you will you would generate the forecast using 3-month moving average. We have to calculate the forecast error here, which will simply equals to actual value, which is the actual sales minus forecast. And we will again drag this one down to get the error for all the months here. Absolute forecast error is simply the absolute value. So I will say absolute of forecast error will give you the absolute forecast error here. So we'll send it down. Square error will be simply equals to our forecast error, and I'm going to use this caret symbol, which is shift 6 then 2 here to get my square error here, and I will send it down again here. Percent error will be equal to the forecast error divided by actual sales, which is 105 times 100. That will give me percentage error, and again I will drag it down, and then we will calculate the absolute value of this percentage error. That will be simply equal to absolute G30 here. Hit enter and send it down here. So this is how we will calculate all the different columns here. We can calculate the sum here, so equals to sum of my absolute forecast errors. Okay, so it should be equals to sum of all my forecast errors, and I can simply drag it to the right here. We don't need a summation for percent error, so I will delete that value here. So we are more interested in calculating this mean values of absolute error, mean values of squared error, and mean value of absolute percentage error. So here we will simply use average function, average of mean absolute error. So I will select up to 12th month. So that gives me mean absolute error. So likewise, I'm going to do it here. Average of my all square errors up to 15th, up to 12th month. And here we're going to do average of absolute percentage error up to 12th month. So we calculated all the forecasting accuracy measures here that needed. Now these are different measures. They don't mean anything. They just tell you that this is how much error is present in this forecasting method. Is it good? Is it bad? We don't know. We have to use other techniques like exponential smoothing to compare. So right now what we'll do is I'll plot this forecast in the graph. So I will select all these first 3 columns, go to insert and plot a chart here, and then I'll add the series axis title here. So on x-axis we have month, and here we have amount or sales slash cost. So this gives you a nice comparison between the actual values and the forecasted value here. Again, when we'll do for another method, then this might make more sense. But here we don't have forecast for the first 3 months because we are using first 3 months to generate the forecast for the 4th month. So this is nicely tracking the variation in the data set, although it's off a little bit some point of time here, trying to smooth out the variation. So next we are going to do part C here, where we have to compute the exponentially smooth forecast for alpha equals 0.3 for this time series. We have to compute a forecast for the 13th month also, and we need to compute MAE, MSE and MAPE for this method here. So I will use the same table, nothing will change. So I will copy that table and put it here. So that's a ditto copy of the above table there, so that I get all the formulas here. Or the only thing that will change is the forecast, and this is how you generate forecast for exponential smoothing method here. So for the second month forecast here, that will be equal to the actual sale of the last month, which is 105, and for the third month the forecast will be equals to alpha, we need to press F4 to make it absolute, times my recent last month sale plus 1 minus alpha plus F4 times my last month forecast, and then I will simply drag it down here. Okay, so I will highlight this one here. So since all the formulas were already there, the entire thing is being populated for me automatically, and you see the curve here. The curve looks a lot more smoother compared to what we had here. And if you compare the, let's say, MSE, mean square error, it was 111 in while using 3-month moving average, and it went down to 510 using exponential smoothing method. So exponential smoothing method is producing more accurate forecast. That's how you compare. So next what we're gonna do here is, so one question here you might ask is, what is the optimal value of alpha? See, if you have too many variations in the data, then you want to use lesser value of alpha because you don't want to overreact to the variation. While if there are not much variation in the data set, it's very stable, then you want to use higher value of alpha, because then you do want to quickly adapt to the changes in the data series. That's something you have to keep in mind. So next we will do part D here. We have to use Excel solver to find the values of alpha that will minimize mean squared error here. So my part D here is exact copy of part C here. Nothing is changing here, so you will see it's a duplicate data set there, with all the calculation. All we have to do is we have to use solver to find the optimal value of alpha that will minimize my mean square error. So for that, what I will do here is I will go to the data, I will click on solver. This time I want to minimize mean square error, so I will click on that one. I will say minimize by changing cell value of my alpha 0.3 here, and subjected to constraint, we're gonna say my alpha value has to be less than equal to 1, because it's alpha, it ranges from 0 to 1. I'll say okay here, and make unconstrained variables non-negative. So we're going to check this box because alpha cannot take negative values, or it cannot be negative. So GRG nonlinear is selected here. All we have to do is click on solve here. As soon as I hit solve here, you'll see the values changing here and here as well. I'm going to say solve here, and we'll say okay here. So solver has found the optimal solution. 0.03 is alpha value, and that has minimized our mean square error to 459 here. Now as you see, the graph is also updated here, but if you compare the forecasted graph here, it looks like a flat line. Here it was tracking the variation, but here looks like if you don't make any changes to the forecast, or more or less if your forecasts are constant over the period, it tends to produce a better solution in this case. So that was how you do it, part D here. Next we are going to do part E. which says that compare the 3 weeks moving average forecast with exponential smoothing forecast using alpha equals 0.3 and with exponential smoothing forecast using optimal value of alpha found in step D, which appears to provide better forecast based on MSE. So what I have to do is I have to copy all these MSE values here. So for 3-month moving average it was 811, for alpha equals zero point 0.3, exponential smoothing method MSE was 510, and for Excel solver we found the alpha value of 0.03 that produced mean square error of 459.69. So all I'm going to copy those and put it in this nice table here. We are tracking mean square error here, and we are comparing the 3 methods, and out of 3 methods our Excel solver produced the best result because it's producing the minimum, or it's minimizing our mean square error measurement. So Excel solver produces the best result. So exponential smoothing method with alpha equals 0.0325 works best. This is how you would solve simple forecasting problem using Excel, MS Excel. Thank you very much for watching. Greg, I'm done.